Welcome to the third episode of Explaining Blender. In the last episode, we explained the keyframe, and this episode continues from where we left off, and we will explain the graph editor. So, the first thing we'll do is move the cube. You place a keyframe, then go to frame 60, and move the cube along the y-axis, like this, and place another keyframe. Now, if you look, you'll notice the cube starts moving. So, what is the graph editor? In short, the graph editor is a tool in Blender that lets you adjust your animation, but not using keyframes like in the timeline. Instead, you edit it using curves. Now, what's the benefit of the graph editor? If you play the animation, you'll see that in this part it's slow, then it speeds up, and then slows down again. But I want the animation to start fast immediately, and then slow down later. This kind of adjustment is only done through the graph editor. Now, how do you open the graph editor? You open a panel from the side, drag it to open a new window, and choose Timeline. And from that menu, select Graph Editor, or simply press Ctrl+Tab to switch directly to Graph Editor, since the buttons we need aren't available in the Graph Editor. Now, once you're in the Graph Editor, you'll see curved and straight lines. What are these lines? Some of them didn't change. No animation happened on them. If you expand the panel, you'll see which ones had animation. So, choose the one where you applied animation, for example, the y-axis, and press Shift+H to hide the rest. If you look to the right of the screen, you will find the values that move the cube. To activate them, go to the View menu and enable the Show Sliders option. The graph shows vertical and horizontal numbers. The horizontal numbers represent frame count. For example, your animation ends at frame 60. The vertical numbers are coordinate values. The animation starts at 0, so you'll see points at 0. Then, at frame 30, the coordinate might be 5. By frame 60, it might be -10.2, meaning it dropped below 10 and a little. What are these points? There are main and side points. The main point is your keyframe. Moving it changes when the animation starts. For example, if you move it to frame 20 and play, the animation now starts at frame 20. The side handles, the two other points, control the shape of the curve. You can move them using G or rotate them using R. Now let's talk about navigating in the graph editor. Use the scroll wheel to zoom in and out. Hold Ctrl+Scroll to pan sideways. Ctrl+middle click lets you zoom into a specific part. Now let's talk about understanding the shape of the animation through the graph. From frame 0 to 20, the curve is shallow, so animation is slow. Then, the slope increases, so animation gets fast. In Blender, the rule is steeper slope equals faster animation. Gentle slope equals slower animation. To adjust the graph shape, select the side handle, not the main point. You can scale it, which can make the animation pause briefly before moving again. You can rotate the handles to change curve shape, which you may not want. You can move the handles with G or R and scale them with S. Now, sometimes when you move one handle, the other one also moves, which you may not want. To make handles move independently, select all the points, press V, and choose from the Handle Type menu. There are 5 options. If you choose the first one, which is free, you'll be able to move each keyframe handle independently without affecting the other one. Same goes for this point. You can move it without impacting any of the other points. If you set it to Aligned, it connects the points before and after the keyframe in a straight line. That means you can't move just one handle. They'll all stay aligned on the same line. If you choose Vector, it makes the curve sharp with a hard angle, rather than smooth like it was before. Automatic means Blender automatically adjusts the handles to make the animation smooth. So when you move one point, it tweaks the surrounding points to keep the motion fluid and not harsh. If you choose Auto Clamped, it's similar to Automatic, but it prevents overshoot, which means the values won't go beyond the next keyframe. All right, we'll keep it on automatic for now and start adjusting our animation. Let's say we want to animate something, like this point here. How would the animation look? It would start fast, then gradually slow down in this part. You can scale it so it becomes faster here and the motion stays smooth. Now, do I always want to manually tweak every keyframe in the graph editor? Not necessarily. You can define the curve behavior more easily. Just press T and choose the type of animation you want. For example, linear. The animation stays at a constant speed. There's no acceleration or deceleration. This feels unnatural. Constant. There's no movement between keyframes. It jumps directly from one to the next, like a sudden switch. If I select all the keyframes and choose Bezier, it goes back to the smooth automatic curves Blender uses by default. Now, there are other options you can try to explore how your animation feels. As a test, let's take an animation curve we didn't create, like this one. Without even playing it, you can tell from the curve that it starts slow, it's barely sloped, and gets faster around frame 40. So it begins slow and speeds up. When you play it, that's exactly what happens. Slow start, then it speeds up. Now, if you choose something more random like this one and look at the animation, it moves up and down in a bouncy way, kind of like a spring. Same here. You'll see it behaves like a falling object. After covering the animation part, let's talk about modifiers. You can select a curve and add modifiers to it. For example, the noise modifier adds a jittery effect to your animation, like an electric shake. Adjust the strength to see the effect more clearly. You'll notice the animation has a sort of vibration. If you remove that, you can try the built-in function, which gives a similar noise-like result. If you enable this option, Blender applies the chosen shape directly to your curve. We will explain modifiers in depth in the modifiers episode. But for now, let's do a practical application on the graph editor and keyframes. Now that we've learned how to use the graph editor and how to adjust animations, it's time to move on to a practical application. We're going to create an animation of a Rubik's Cube that breaks apart into smaller cubes and then reassembles itself. First thing you need to do is make sure each small cube is a separate object. They shouldn't be connected together or share materials in a way that makes them stick. Every cube needs to be its own object. After that, select all the cubes, then go to Set Origin, Origin to Geometry. This ensures that each cube has its origin point in the center of itself. Let's pause for a quick note on Blender's interface. Blender has a lot of menus, way too many to memorize just by watching someone list them off. Watching a video where someone walks through every menu for hours isn't helpful. It's better to see menus being used in real examples. So that's what we'll do. Today we're focusing on the Snap menu, which you can open by pressing Shift+S. This menu is mainly used to control the 3D cursor and object positioning. Let's say you choose Cursor to World Origin. This puts the cursor at the center of the world. 0, 0, 0. If you choose Cursor to Selected, the cursor will automatically move to the object you have selected. If you choose Cursor to Active, it'll move the cursor to the last object you selected. For example, if you selected multiple cubes and then one more at the end, the cursor will snap to that last object. Another option is Selection to Cursor, which moves your selected objects to wherever the cursor is. But note, they'll all move to the exact same point, so they'll stack up. If you want to move objects to the cursor's location, but keep their spacing, choose Selection to Cursor. Keep Offset. This moves the group, but keeps the relative distances between the cubes. You can also choose Selection to Active, which moves everything to the location of the last selected object. Some options like Cursor to Grid or Selection to Grid are rarely used. They just snap to the nearest grid point and aren't that useful in most workflows. Back to the cube animation. Make sure you've done Set Origin to Geometry, then move the cursor to the center of the original cube. Now add an empty object. Select all cubes, press Ctrl+P, Object to parent them to the empty. This way, when you move the empty, all the cubes move with it. Now we can begin the disassembly animation. You can do this manually by going to frame 80. inserting a keyframe, then going back to frame 1, moving the cubes far apart, and inserting another keyframe. It works, but it's a slow and clunky method, especially for 27 cubes. A much easier way is to use the 3D cursor as the pivot. Make sure the cursor is centered, then select all your cubes. In the pivot point drop-down, choose 3D cursor. Now in the transform panel, make sure location is checked, so the transformation affects position. When you scale the cubes, you'll see them move away from each other, as if they're breaking apart. Move to frame 100 and insert a keyframe. Then go back to frame 1, scale them down so they're close together, and insert another keyframe. Now when you play it, the animation will show the cubes assembling or disassembling in a clean way. If you prefer that the cubes don't overlap while coming together, just remove the scale keyframes and instead scale them separately on the X, Y, and Z axes. This prevents them from crashing into each other visually. But personally, I actually like the look where they slightly merge into each other. It gives the animation a nice emotional touch. Now, if you're thinking about animating the full Rubik's Cube rotation, that's a bit more advanced. Even though the cube looks simple, it's made up of 27 smaller cubes, each rotating differently. That makes the animation very complex. If you open the Grapheditor and press Ctrl+, tab, you'll see how messy the keyframes get. Each cube has different movement, so adjusting them individually would be a nightmare. That's why I used a pre-made animation. You'll see that the animation plays smoothly. If you want to change the ending, for example, to prevent the cubes from merging into each other, you can go to the last keyframe, delete it, then scale each axis, X, Y, Z, and insert a new keyframe. This version avoids overlaps, but honestly, I think the merging look feels better. It adds life and flow to the animation. As you saw, we didn't really animate the full cube's motion yet. That would take a lot of time. But I'll show you how I did it in a later episode. Basically, I created the cube animation, added a jet engine effect, some electric sparks, and a rotating sphere. Then animated the camera, and that gave the final polished result. That's how the full animation was built, and we'll break it down step by step in the next video. So that's it for today. Thanks for watching, and see you in the next episode.